All right, welcome everyone. Make sure you're in the right place. Cal 2, yes. Robert DiGiovanni, that's me. Let me get us to our course. I'm going to assume everybody can get in here and get to Canvas and get into the class. Yes. All right, so not going to go through this whole thing because it's too much to go through. But there is a quiz that you have to submit. It's just a confirmation saying that you've read the syllabus, you understand the requirements of the course, how the grade is broken down. So just complete. It's a yes or no question, and that's due in 2 days. All right? What's that? 2000. Yes. So it's already past due. So hurry up and submit that, please. It's still open. I just forgot to change that right there. Yeah, it should still be available to you in Canvas. And then let's see the schedule. I recommend you go ahead and download this and print it out and just bring it with you. This is going to show you. Ooh, gosh. What we're going to be doing day by day. Hopefully, we can keep this pace. And when we have holidays, when exams take place, and so on and so forth. So every time we cover a topic, these are the problems out of the textbook you should do for homework, all right? And we have, 2 exams, 3 exams, and then a final. And I don't have the final exam date yet because they had not published the calendar. When I put this together, they had not published the calendar, so, all right? Am I moving too fast or is this okay? I'm assuming all of you have some experience in college at this point, so okay. Class lecture videos, so that's what my recordings of this class, that camera will be in here every day. Whatever I do in here, I'll push it out to YouTube. It'll be there later. You can watch it, okay? So that's the link that takes you to the playlist for your class, all right? Right now there's nothing there. And then all those homework problems that you have listed here, oh, no, I guess I closed it, never mind. All the homework problems that were listed there, I've already worked all those homework problems out on video. So this is like a solution manual, but it's actually just me working through all the problems. So you can kind of look at these and get an idea of how long certain problems or certain homeworks are going to take you. Like maybe when you get to 6.2, it's 2 parts, 2 videos, and it took me almost 3 hours to do the homework. Right? So that gives you an idea of how much time you should, plan on investing. And yeah, so everything's there. I recommend that you use those videos properly. Don't just watch them and be like, yeah, I could have done that if I had to do it. It's better for you to work a problem, maybe, watch the first part of the video, pause it, make sure you're kind of doing the same thing, and, use it in a way that helps you rather than hurts you, if that makes sense. Questions on that? That's it. That's on our main page. The grades will appear there when it's time. The syllabus. So this is the important thing that you have to read and sign off on. I'm just going to hit major points. I give you my cell phone number. You can text me at any point in time. I just ask you that when you text me, it should be something to do with like a problem you're struggling with. Take a picture of the problem, take a picture of your work, send it to me through a text. I can kind of find where you're making mistakes and send you a reply. If you're not going to be in class, don't text me, send me an email, all right? If something like that, that's not time critical, then just use email. The texting is more for things that, don't want to have to wait 24 to 48 hours to get a reply on, all right? Also make sure that when you text me, include your name and what class you're in. So I'm only doing, I'm doing 2 Cal 2. So Just say you're in my, this is whoever from your Monday, Wednesday, Cal 2, all right? My office hours are listed here. Unfortunately, well, today, yeah, I do have good office hours, I guess. Maybe they may or not work out for you, but immediately after this class, I'm in my office until 2:15. So maybe that works for you. Earlier today, no, I'm not in my office. So that's it. From today, or for today, it's just 12:45, 2:15. Tuesdays, Thursdays, I have a bigger chunk when I'm in my office. So you can come in for help. And then on Fridays, you can make an appointment with me if you want to come in and talk or get help on anything. All right? Questions on that? All right, the textbook for the class is this one. We use the same textbook here at this college. We use the same textbook for Cal 1, 2, and 3. So this is the book we're using. And yeah, it's an old edition, so you should be able to find this cheap, probably online free or something. I don't know.
Chegg, it's $24 to rent.
Chegg, it's $24 to rent. Okay. For how long? For one semester? For one semester, okay. 15 on Amazon. Yeah, well, I'm out of that. Okay, so in terms of calculators, you'll probably want a calculator for the class. Graphing calculator is okay. The one thing is, on exams, I will not allow you to use a calculator that has a computer algebra system on it. So if it can do integration and it can do differentiation algebraically, you can't use it on the tests.
So 89's out.
89's out. The TI Inspire CAS, C-A-S. TI 92, I don't think they make that anymore. But anyway, if you have a question, let me know. And if that means you have to go buy a new calculator, I don't want you to have to do that. I can check a graphing calculator out for you for the semester. For those people who have like a TI 89 in, you know what I'm saying?
I have both.
Yeah, if you have both, great, yeah. So on the test, I will expect that you are not using an 89. Questions on that? Let's see here. The description of the course, I'm not going to read this. I'll talk about it a little bit later. You can read. Evaluation, your grade. Quizzes, I will give quizzes. Those quizzes will come in the form of just random like pop quizzes, if you want to call them, where everyone has to work alone. I may do group quizzes. I may do take-home quizzes. I may do attendance quizzes like, hey, you're all here today. Sign this sheet of paper. Everyone gets 100. It just depends. Just always expect a quiz at any point in time. I will normally quiz you on material that we covered the previous class. All right? So the expectation is that whatever we do today is fair game for a quiz next class. All right? So plan on working on the assignment. I guess what I'm getting at is don't plan to come to school and do Monday, Wednesday class and do all your homework on the weekend. You're going to need to do some stuff between Monday and Wednesday to be prepared. And that's just because this class builds on itself. So you can't afford to wait for the weekend to practice. So we'll do a quiz. And notice there's nothing here for homework, right? So the homework is completely on you. I'm not going to take it as a grade, but I can assure you that if you don't do your homework in this class, you're not going to do well. And I know you've been told that from the beginning of math, that if you don't do your homework, you won't do well, but I can guarantee you in this class that if you don't do your homework, you won't do well. Like it's guaranteed. So at the end, I might do some sort of homework bonus grade at the end, where if you show me at the final exam, you bring in all your homework for the whole semester, say, hey, here's all my homework. It should be a big thick binder like that of homework. Then if you show that to me, then I may consider that as some bonus in the class. So keep your homework all together and bring it to class every day. Because I may give you a quiz where I say, hey, do this problem. You can use your homework. If you don't have the homework, then it's not going to help you, all right? 3 exams and a final. Notice the first exam is only 15% of your grade. The reason why is because it's going to happen pretty early in the term, and it's not real heavy in terms of material, difficult material. It's kind of easy material. And so the real heart of the class is everything from exam 2, 3, and 4. And so they're worth more. Policies here, attendance, of course you need to be here 4 times. You can miss 4 times after that. You can be withdrawn or dropped. Like this what to expect has to do with the fact that I'm going to be recording my lectures, blah, blah, blah. This right here, this electronic policy, device policy, I don't mind if you're using your laptop because I do provide you a lot of notes online. But what I just don't want is for you to be doing something other than math in here. So don't be fiddling around on your phone. Don't, you know what I'm saying? Like texting people, updating your whatever's popular now, Instagram, whatever. Just keep all that out of the room. If you have to do it, if you must, just walk outside and do it in the hallway and then come back. All right? And then don't sleep in class. Those are the 2 things. Don't mess around on your phones. And don't sleep in class. The consequence is a 10% penalty on your next exam. So I'll actually be like, you know.
Getting on the Wi-Fi for
Yeah. So like I'm using you as an example because you have it right there. So if you're there like doing something on your phone, first thing I usually do is I would call on you to like help me with that problem. And if you're like, then I start wondering why you're in your phone or your iPad or whatever it is. And then I'll get to the point where I'll take the 10 points away. All right, so I don't know. Some of you have had me before, right? So did I ever do that in your class? Who got it? You got it. It was like the first day, right? Yeah, so like the first day. Yeah, okay. So I don't think I actually took the 10 away, did I? I didn't. Yeah, but I did call you out.
I do have a question.
Yes.
I remember last semester you did make the comment about like sleeping, and you were like, if I wake you up and you can answer my question, then you can go back to sleep.
Dang.
I don't think you remember that the same way I remember it.
I watched it.
No, really?
Probably gonna fall asleep in class.
Maybe I did say that, but I'll say here that if you're sleeping in class and you understand the material, then just don't come to class, right? And then you get that 4 of those, okay? And catch up on your sleep. Yeah.
11 o'clock in the morning though, like, come on guys.
Yeah, well, you know what? I mean, you never know what people do for a living. You never know. How many of you work? Okay, I mean, how many of you work more than 30 hours a week? Okay, so, I mean, people work night shift. I mean, it's... Okay, cheating, no cheating, right? I don't do slaps on wrists for cheating. I just drop you from the class, or I give you an F. Tutoring, blah, blah, blah. SOBI, this is about the fact that we're in 2019 and people like to go around and shoot people with assault rifles. So we want to make sure we're keeping an eye on people around us. If people are acting weird, if you see someone in the hallway, if you see someone out in their parking lot with duffel bags and trench coats, and you know, you'd probably just want to let someone know, right? And one of the things, the most important thing for us in here is, you know, us having a plan of what to do if there's an active shooter. So we know that that's an exit point. You can go left or right. You can find exits, right? But if we actually have to barricade in place, I believe we can still get out here. Let me just double check that one, maybe not. Oh, gee. Yep, okay, so there's an awning right here. I mean, I think the awning is actually right, this level right here. So it would be like, just, we have to breach the window, but I think in that circumstance we could. And that's an exit point. Go down the awning, jump off the awning onto the ground. You might twist an ankle, blow out your knee, but you won't be dead. So that's an exit point, all right? I would like to keep the door locked during class. I don't think I did a good job of that last time. So if you have to leave to use the restroom or something else, just if the people over here don't mind opening the door. I was told in a meeting the other day that the only, hey, perfect, yes. Come on in. I was told in the meeting the other day that the only mass shooter that actually breached a door was the one in Newtown, the one that killed all those kids. Had to breach the front door of the school, but he just shot through the glass and walked through. So having a door between us and whoever is a good thing. So we're going to keep that door locked, even though it's a wide open window. You know, it's still a door you have to get through. So, all right, 2019 is a wonderful, isn't it? Okay, so pay attention, keep an eye out. That's an exit point. That's where I'm going. Okay. All right, The schedule we've talked about, blah, blah, blah. Yeah, okay. Any questions? Yes.
As far as like, outside of like homework, I know you said that at the end we could like submit all our homework that we did for a potential bonus or whatever.
Let's just make it official. If you keep all your homework together in a folder binder, shows you've put in a lot of effort, I will count as bonus at the end of the class. I'm not sure how much, maybe 5 points on the final or something like that.
My other question was like, as far as like bonus like on exams, bonus on quizzes, like extra credit possibilities throughout the semester, not just on exams, but like extra credit that we can do to help with a grade, anything like that. Is there any of those things that you include?
They'll pop up throughout the class. I'll be like, hey, here's a problem. We're not going to do this one. We don't have time. I'll offer it as a bonus. There will be different opportunities for that for bonus, more challenging problems, things like that. Any other questions? Okay. All right, so we're going to try something a little bit different here for those of you who've had me before. I'm going to call your name and I'm going to hand you a clicker. Now, I've used these in the past. I don't know how this is going to work. I'm going to be able to kind of keep a real-time poll on the right-hand side of my screen of kind of where everyone is. So like it's going to be like a live polling. So as you're sitting there, I'll be like, do y'all get it? Do y'all get it? And if you don't want to tell me no, you can tell me no through the clicker. And I'll have like a percentage of how much of the class is with me, how much of the class is not with me. Does that make sense? Okay, but these are actually linked to you. So I'm also taking attendance off of these. So let's see, Mohammed.
Yes.
Let's see, you're number one. And let's check this. Go ahead and grab that one. Let me see if this is going to work. I don't want this to become a distraction in the class, so this first time we'll get things set up, but from here on out, when you come into class, you're going to find your clicker. They're all numbered. You're going to find your clicker, your number one, and you'll just come get it out of here, and you'll go sit down. And then at some point, I'm going to ask, I'm going to take attendance at the very beginning, and this is what I'll do. So I'm going to take attendance. Just hit number one. Okay, so you're number one. Number two is Arafat. Here, come grab these. Luis, sorry, he did it again. Jacob. I'm going to call you and your number. Jacob's number 4. Yep. Corey is number 5. Heidi, number 6. Don't click them yet.
Number 6. Chase.
No.
Chase.
Let's see who this is. Yeah, that's 7. You're 7.
Oh, this guy.
Let's see. DeLuna. These are in order. Erica. Okay, Arafat, hit yours. Okay. Luis. Number 1. Say number 1. Jacob. Heidi's good. Wait, Heidi, was that you?
Yeah.
Okay, Jacob. Number 1. No, I'm saying hit number 1.
Oh.
Yeah, sorry. Okay, Stephen. Yeah, this is probably better. So that's your number for the rest of the class. Christopher. Tatum. Rasul. Edward. Octavio. Make sure that's you. Okay, Jordan. Oops. Maxwell, that's you. All right. And Christopher. Let's see. Johan? No? Gabriel? Jeremiah? Can you hand that over to Jeremiah? Let's see. Martin? Okay, that's you. Ricardo. Right there. Almost there. Jonathan? There you are. Gina? Did I say that right? Gina? Okay. And David? Oh, here. My voice. You're throwing your voice. I already clicked it. Michelle? And that's it. Okay. Everyone has a clicker? Anyone not have a clicker? Okay, so let's just to show you how this will work. So I'll say, okay, we're going to take attendance. You hit number 1, and then once that's done, you were here today. All right? Then I can start a poll now. Okay, so now let's say I'm gonna probably keep this over to the side. Don't know how. I can't make it any smaller. That's one thing about it I'm not happy about. I think that's as small as I can get it, so it might actually kind of get in our way. But my plan is to have it here, so I'm like, okay, I went through the syllabus. Are y'all good with the syllabus?
First A or B?
So A is 1, okay, that's yes, and 2 is no, all right? Or B is no. You get the idea? All right. So a couple of people aren't happy with syllabus. Get it? So now once you've done that, right, you can't change your answer at this point. So then I might make it where you can change your answer.
They are changing their answer.
Oh, you can? Okay, then I do have it set. I just reset it. So what I'm trying to do is have this, as I'm going through an idea, kind of always have that thing over there and be able to like see where we are. Does that make sense? And if I get too much red, then I'm like, okay, so what's the deal? Like what don't you get? And then that forces you to have to engage me, you know? I don't know. We'll see if it works. All right. Anything else you want to talk about before we get into this? Yeah, for now, let's see, where's that? Is that thing going to hide my window? There it is. So I'm going to see if I can just kind of work in this space for right now. All right, so what about Cal 2, right? We've all heard this is the monster class, right? We all heard that? Have you all heard that? This is the one? This is the beast? No? We'll see, I guess. We'll see. Usually this class will test your abilities. I mean, it's going to challenge you, even if you were really fine in Cal 1. Cal 2 usually challenges you, and it's because the material itself can be difficult, but then it's also the pace. Like the pace is just unrelenting. In fact, it gets harder at the end, and by that time you're kind of burned out. You're kind of tired. You have what, Thanksgiving break, right? It's going to be in here somewhere, right? So it just never lets up. But let's not get ourselves discouraged or anything. I don't want you to feel like that. You know, you put in the time, you put in the effort, and things should work out well for you. All right. But let's talk about Cal 2, like what it is. So maybe we can talk a little bit about Cal 1 first. So what was the main theme in Cal 1? Derivatives. The derivative, right? So Cal 1 is often called differential calculus because it involves the derivative. And what is the derivative? I mean, if you had to explain it to just a common person.
Determine the rate of change. Essentially, like, how long does it take to get from one point to another?
Okay, so rate of change, I like that. At an instant. All right, so we were able to figure out an instantaneous rate of change. Geometrically, what it meant was if you were to take a function that changes, that's constantly changing, right? It's not constant. It's not a constant change, but it is changing constantly, always different. Then you could go to any point on that graph and you could compute the slope of that, I missed it, the slope of the tangent line. And that slope would represent the instantaneous rate of change of that function at that point. And to get to that took a lot of work. We had to introduce the idea of the limit. Once we had the limit, then we could define the derivative as limit as h goes to 0 of f of x plus h minus f of x all over h. Does that difference quotient thing, right? All that stuff. So we did a lot with just getting to the point where we could actually talk about the derivative. And then, what else did we do in Cal 1? It's not, I mean, we got slopes of tangent lines, but what else was in there? What were some of the things you didn't enjoy too much? L'Hopital. You didn't like L'Hopital?
Rate of change.
You didn't like L'Hopital. Didn't you miss class during L'Hopital? Well, then there you go. Okay, so L'Hopital.
I did not like related rates.
Related rates.
They were the devil.
So what? Give me an example of like a related rate problem.
Ladder pulling from the wall.
Ladder sliding down a wall, right? A balloon is being inflated at a certain, so many cubic inches per second. How fast is the surface area changing? Those types, word problems, right? Okay, so we had related rates. We had L'Hopital's rule. Okay, who in Cal 1 did not see L'Hopital's rule? Did not?
I took a summer class and
Did not. Okay, so we'll need to fill that in at some point. That might be a visit to my office or something. Okay, it's not terrible, but without it, you'll be kind of crippled in certain places. So that goes for anyone who didn't see L'Hopital, all right? What else did we do in Cal 1?
Antiderivatives.
So at the end, usually you do little antiderivatives, okay?
I really like Riemann sums.
Riemann, so you did the Riemann sums, your class did, yeah. So the Riemann sums, in my Cal 1, we don't compute them by hand. We talk about them, and then we say, we could torture ourselves with this, but at the end of the day, you're going to wind up having a nice formula. So, yeah. So if you didn't do Riemann sums, it's not going to be the end of the day for you, all right? It's okay.
Area under a curve.
The area under a curve, so that's also related to the antiderivatives, right? So that towards the end. Chain rule. Okay, so we had to learn, that's when we were learning about taking derivatives, right? There were these rules. Power rule. Quotient rule, product rule, chain rule, right? Those are the big ones. And if you couldn't do any of those rules, then you would be in trouble, right? Like if you can't differentiate a function, if you still aren't comfortable with the chain rule, if you still can't do a product rule, this class is about going backwards. So it's going to be difficult to go backwards if we can't go forward easily. So
Continuity and piecewise.
continuity, mean value theorem. These are all little ancillary topics that you cover. How about optimization? I'm not hearing anyone say that at the end, optimization.
Still didn't like them.
Yeah, because they were word problems, right? This optimization and the related rates are always difficult because they are usually word problems and students struggle with those. But optimization is probably the most important takeaway from Cal 1. Like taking derivatives is fine, but for, why? Like what would you ever need that for? Well, for optimization problems, you have some sort of function, you're trying to find its highest and lowest points. The optimization allows you to do that. So that's where we can minimize the cost of something or maximize the volume of something. So these problems are very useful in the real world. Okay, so that's Cal 1. How about Cal 2? So what is Cal 2 going to be about? Well, we're going to have some overlap. So we're going to talk about antiderivatives. In fact, I'm going to assume that you never saw them. All right, so I'm going to start from ground level with antiderivatives. All right. And as far as Riemann sums, I'm going to talk about Riemann sums too. So again, in Cal 1, it depends on your exposure, how far you got into this. So I will talk about Riemann sums, but I'm not going to get too deep into it. Areas under curves. So what we do is here, instead of trying to find the slope of a tangent line, what we do is we say, if we have a function, can we find the area underneath that curve? And that's going to have to do with the antiderivatives. But that's not all that Cal 2 is about. I guess I haven't talked much in a couple of weeks. My voice is not happy. Anyone know anything else about Cal 2? Things that we are going to do in here? Was that your hand or no? So antiderivatives and areas under curves.
There's something with the trigonomic functions.
Trig functions, yeah. So we're going to make sure we have all the different types of trig functions covered. We've all learned sine, cosine, and then there's arc, cosine, arc, tangent. So the inverses, and then hyperbolic trig functions? Yes.
It's more the game, like revolve base.
Okay, yeah, so what we wind up doing is we start taking this figure, we imagine rotating it around like the x-axis. You can imagine taking that, making it three-dimensional where we rotate it around an axis and look at the volume of that solid. Like, what's the volume of that, or what's the surface area of that? So that we're going to start looking at some geometric things. Anything else you may have heard about? Yes?
UV minus EDU.
Okay, so that has to do with antiderivatives. You know how when we were taking derivatives in Cal 1, there was power rule, product rule, quotient rule, chain rule? Once you learn those, you're in business. You can pretty much differentiate anything that anyone gives you. In Cal 2, when you're trying to do antiderivatives, you're trying to go backwards, there is not a list of 5 rules that I give you. It's actually these techniques that we have to learn, and they're not easy. They're not easy in terms of, do you agree that when you take a derivative, the power rule, product rule, quotient rule, and chain rule are very systematic? You could, I don't want to say teach them to a monkey because it's not that easy, but it's a process, right? It's just like, okay, you bring the power down, you subtract 1, or if you have a product rule, you do this one, derivative of this times this, plus derivative of that times that, right? It's very, very much like a formula. But in Cal 2, when you're going backwards, it's almost like we're doing like magic, like pulling rabbits out of hats. It's not as procedural, follow this step, this step, this step. So that's where most students struggle, and that's what you were mentioning, the UV minus whatever. That's a formula we can use. Anything else? I don't know. We may not be going today. Yep, let's call it a day. All right, so let me tell you some other things we're going to do in here. We're going to talk about series. All right, so all this stuff is all great. Series is going to be the big chapter. Okay, this is the one that causes the most issues with students. This is chapter 8. So chapter 8 has to do with the fact that when you look at a function, like, let's take the function e to the x. If I were to go and ask you right now what e cubed is, what would you do?
Are you asking for a derivative, or just?
No, just what's e cubed? Okay, you did it, right? What did you do? What did he do?
Got a calculator.
Go ahead, do it.
20.
What is it? Approximately what?
20.0.
20.09.
9. Oh, you want more? Oh,
Yep.
20.0855.
855. Okay, we'll stop there. All right. So what did your calculator just do?
Approximate.
Okay, but what did it do to get this number? Like if I asked you to do 4 squared on your calculator,
Oh,
what would your calculator do here? It would do 4 times 4, right? No problem. But when it does e cubed, it's doing e times e times e. But what's e? Approximately 2.718, right? So it's doing like 2.7. But in fact, that's not at all what it's doing, all right? It's not doing e times e times e. What it's doing is this. It's using the fact that e to the x is actually 1 plus x squared over 2 plus x cubed over, I'll do it this way, 3 times 2 plus x to the 4th over 4 times 3 times 2 plus x to the 5th over, and this pattern keeps continuing forever, all right? So what I'm telling you is this. When you type in e to the 3rd power on your calculator, your calculator does 1 plus 3 plus 3 squared over 2 plus 3 cubed over 3 times 2 is 6 plus 3 to the 4th over 4 times 3 times 2. You get the idea? And it keeps doing this, and it stops at some predetermined thing that whoever programmed that calculator tells it to stop at a certain point, and then it spits out that answer. And if you don't believe it, you can just do this on your calculator. 1 plus 3 plus, what's this? 1?
2/3.
So what, 3 squared is
Oh, no,
9,
one.
right? 9, so that's 1, so we get like 1 plus 3 plus 1 plus, and we keep doing this. And if you go out far enough and stop at some point, you're going to get that decimal, all right? This right here, the fact that e to the x is this, like that's the question. Why is e to the x this? And that's what this has to do with, is how do we start with a function and turn it into this series. Notice this is a series of terms, right? And each of these is a power of x. X squared, x cubed, x to the 4th, x to the 5th, right? And so those are all powers of x. So we actually call this a power series. That's what chapter 8's about. And you can do this for pretty much every function out there in the world. There's another one for sine of x. Sine of x has its own power series, but it's a little different than this one. 5 times 4 times 3 times 2 plus, minus, and then it has a pattern. It keeps going. It fluctuates. All odd powers, though. And do you remember ever hearing that sine is an odd function? It's because its power series is all odd powers. Cosine is like this, but it has all even powers. You know what? My bad. That's an x. Sorry. So what we'll do in chapter 8 is we have to first just talk about series, and there's a lot that goes on, but at the very end we start taking functions and converting them to their power series. And if anyone here is a computer science major, right? Okay, like when you code, you can code up a computer to calculate e to the x because this is what can computers do? Addition, subtraction, multiplication, division, right? That's it. And when you look at this expression, this is all either addition, subtraction, exponent is multiplication, isn't it? Repeated multiplication. So this is all either addition, subtraction, multiplication, or division. So a computer can do this easily and quickly, right? So series is where we get into that whole idea of, well, you'll see. Now I want to show you something on this because this is really kind of fascinating. Kind of getting ahead of myself here. Let me rewrite this. Told you what e to the x was, right? Does anyone know what this thing in the denominator could be rewritten as? Factorial, okay. All right, let's just say that continues. Let me ask you, from Cal 1, what is the derivative of e to the x?
E to the x.
Itself, right? So what would happen if I take derivative of this? So if I take derivative of this, right, I'm supposed to get itself, right? Okay, let's try and take derivative term by term. What's derivative of 1?
0.
What's derivative of x?
1.
Okay, plus, now what happens here? The 2 would come out, right? And cancel with that 2, and what would you get?
X.
Okay, plus, here the 3 would come out and cancel with that 3, and you would get x squared over 2 times 1, plus, here the 4 would come out, cancel with the 4, you get x cubed over 3 times 2 times 1, right? And what is this? That's that, right? They're the same. Look, right? 1x, x squared over 2, x cubed. It's the only function that does that. There is no other function out there that behaves that way. It's pretty interesting. All right. So we're gonna explore a lot of different things in this class. Yeah, our attack on this, our approach is going to be to start. The way we do the calculus 2 here is that we start with some stuff with trig functions. We talk about antiderivatives, and then we basically say, let's try and make sure we're masters at taking antiderivatives. Like, let's make sure we can take the antiderivative of anything that they hand us. And then after that, we start doing applications. All right, so it'd be like in Cal 1, we learn all of the rules for taking derivatives, and then we go do applications. That's the way we're going to do it here in this class. So we're going to start in chapter 3, jump to chapter 5 for a little while, then to 6, then back to 5, and then to 7. So we're going to be kind of jumping around in the book, just so you're aware. That's the way the math department has decided to do this here. How many of you got this thing I handed out, or that I sent email? Anyone not get it yet? Okay, these need to be filled out. This is your first quiz. Anyone else?
I didn't even do the letters.
That's okay. Everyone else has it? All right, so I don't want to take any time out of class right now for this. Maybe if we have some time at the end. The whole idea behind this is to help you think about your time management and how much you have on your plate and how much you're expecting of yourself. Because sometimes people just put too much on their plate. I had a student last semester, and I felt for this guy. I mean, I really wanted him to get through the Cal 2. I really, really did. And he was just working like 50 hours a week. He'd come into class, he's just exhausted. He was trying and, just didn't. And I told him in the very beginning, I was like, man, you just have too much. It's too much, but you do what you can and see how it goes. So this is just for you to reflect upon what you're trying to do here, because this class requires a lot of effort, a lot of work. So let's put this away for now. And there's a part on here where I asked you to get with some classmates and try and exchange some names and numbers. This is optional. I'm not requiring you to give someone your phone number. If you're not comfortable with that, that's fine. But I think it would be worth it for you to get 2 or 3 people in here that you can contact and maybe sit and study with. I would look at your schedules, and I would see like who has times that you have time. Y'all have the same times to meet up. So maybe you're free on the same day at the same time. I'll give you some time maybe at the end of class where you can kind of fill this out and get it done. All right? And then what I'll do is I'm going to collect it, but then I'll give it back to you. That way you have it as a resource. All right, let's get down to business. Let's do it. I'm done yapping here. I feel like we're missing something. Are we forgetting something? I'm sorry? Oh, the popsicle sticks. Yeah, let me have those. So what I'm going to do is I'm going to go have some custom popsicles put on these sticks for you, and then I'll give them to you at the end of the semester. Yeah, put your name on the stick. Now, what I'm going to do is throughout, in the middle of lecture, I'm just going to pull a stick and I'm going to call on you and put you on the spot. This will help you stay actively participating in the class, hopefully. Now, these tables right here are notoriously bad because your back is to us. So if you want to rotate, if y'all are willing to do that, then everyone at least would be looking sideways a little bit. Might help you out. That goes for anyone. If you need to adjust anything, go ahead. All right, I need more sticks. Is that everyone? Okay. We are going to start this thing off with something you should be familiar with. It's always good to walk in the first day and at least see something that you know. So we're going to talk about the inverse trig functions to begin. First of all, we should all understand what a one-to-one function is. So any function that says here that a function is said to be one-to-one if every output comes from exactly one input. So here's an example of this. If we have this function here, is that function one-to-one? Does every output come from exactly one input? No. Can you give me an example of an output that does not come from exactly one input? Think about it like a diagram here. You have the x's going in, right? This is your domain. And then here's your range, the thing's coming out, right? So this is your function here. So what would happen If you plug in -2, you're going to get 4, but 4 could also come from +2, right? 2. You have an output that comes from 2 inputs, right? There are 2 inputs that would give you this output. A one-to-one function has the property that every output comes from exactly one input. So there's only one, this number over here can only come from one place. So that means it's easy to trace where it came from, right? Because, you know, here if I said, hey, the output's 4 on this function here, you can't tell me if you had plugged in 2 or -2, you'd have to tell me it was one or the other. One-to-one, there's a way to go backwards to exactly one place. So visually, that means that a function has to pass the horizontal line test. So if you look at this, you know, parabola, f of x is x squared, we know it looks like this, right? That obviously fails the horizontal line test. And as soon as a function fails the horizontal line test, hits more than one time, it is not one-to-one, right? So for a function to be one-to-one, it must pass the horizontal line test and the vertical line test. Why does it have to pass the vertical line test? Well, it has to be a function, right? We use the vertical line test to test whether or not you have a function. So to say, does a function have an inverse or is it one-to-one, means that you have to first have a function, pass the vertical line test, and you also have to pass the horizontal line test. Then you're a one-to-one. So let me draw you another picture and you tell me whether or not it's a function, whether or not it's one-to-one. So how about like a cubic function? Is that a function? Yes, pass the vertical line test. Is it one-to-one? No, it fails the horizontal line test. What would be a good example of something that would pass would be a one-to-one function?
Or a hyperbola, which is like linear, or like, yeah.
Linear function. How about just a line? Right? A line would pass the vertical line test and the horizontal line test, right? So that's a very simple example of a one-to-one function. But there's many others. You could have, let me make this cubic function do something a little different. How about if it did this instead? How about just went up like that? Just put a little curve to it, but never really make it come back down and up, right? That would be one-to-one. And we could just sit here all day and draw one-to-one functions. But that's not the point of this. The point of this is not to talk about one-to-one functions. It's to talk about how we get to inverse. So when we look at the trig functions, there's your standard sine function, right? Everyone familiar with that sine function? What's the period of the sine function? 2 pi. What's the range of the sine function? -1 to 1, right? So we're all familiar with this from pre-cal. Okay. Whoa. Is this function one-to-one? It is not. So if somebody gave me an output, like, you know, think about that picture again. You have the inputs, the outputs. If someone said 1 came out, could you tell me where it came from? You can't, right? You can't tell me where this 1 comes from. In fact, I could plug in pi over 2 and get 1, right? I could also plug in -3 pi over 2. But it actually spits out 1 at infinitely many places, right? So you can't talk about this function being one-to-one. Do you all agree? But there is an inverse sine function. There is one, right? We saw it in pre-cal. It's arc sine of x, or you may use this notation, right? We know that there is an inverse to the sine function. So how do we get to that? If this function is not one-to-one, then how can we actually talk about an inverse if it's not one-to-one? What do we have to do? Restrict the domain. We had to restrict the domain of this. So in order to do that, what we did is we said, all right, here's the original sine function in red. And what we're going to do is we're just going to restrict it to that little piece right there. And if you look at that little piece right there, do you agree that on this little piece, we actually still have the entire range of the function? It goes from -1 to +1, right? So since it contains the entire range, if we just cut this piece of the sine function, then we can talk about an inverse there because that's one-to-one, right? Okay, now also, that's not the only place we could cut it. Like, could I have done this? Take this one out. Could I have done that piece right there? I could have done this, right? And that still would have worked. But then someone else could have done something different. They could have done that piece over there, right? So when it comes to the sine function, we all had to agree on where to cut it. And there's a standard place we cut it, and this is it. Okay, that's where we cut it. So when we talk about the sine function, we restrict it between negative pi over 2 and pi over 2. It takes on all values between negative 1 and 1. And then on that piece, we can talk about the arc sine. Does this look familiar? You saw this in pre-cal? Yes? Shall we look at the vote? Do y'all remember seeing this in pre-cal? Okay. All right. What about for cosine? We have to do the same thing, don't we? For cosine? Okay, hold on. My cosine one's down here. Maybe not. I thought my cosine was there. Okay, not an issue. So if we restrict the sine function between negative pi over 2 and pi over 2, then we can define the arc sine function. And all of that is stuff that we messed with in our pre-cal class. We know that when you talk about a function and its inverse, when you graph them, when you graph a function and its inverse together, they are reflections over the diagonal. Do you remember that part? Every time you graph a function and its inverse, it's just a reflection over the identity. Okay, so let's just make sure we got some basics down here. What is arc sine of 1? So this is an example. So it's time to put you all on the spot. And look, remember, nobody in here is going to be like totally devastated if I call on them and they don't know the answer, right? You're not going to walk out of here all, I'm going to go drop the class, and no one's going to be like laughing at you, right? I'm going to hope that you make any mistakes you make are going to be here in class and not on a quiz or a test, all right? So, Gabrielle? All right, Gabriel, sorry. You're up.
I don't remember.
Okay, so arc sine means that you're looking at the output of the sine function, and we're being asked when it's 1, right? So what do you plug in? The other way of looking at this question is saying sine of some angle equals 1, right? That's what this is saying. Arc sine being 1 means sine of some angle is 1. However, because we're talking about the arc sine function, this angle has to be restricted between where? Negative pi over 2 and pi over 2. So sine of what angle? If you're only allowed to look, let's look at like a unit circle. If your angle is between between negative pi over 2 and pi over 2, that's in here, then at what angle is sine 1? Pi over 2, up here, right? Because when you're pointed straight up, sine is always the y-coordinate of that point. Okay? The y-coordinate of that point is sine. What's the x-coordinate of that point? Cosine. So the answer to this should be, let's just put the answer. The answer should be pi over 2. Okay, these are things, this is a pre-cal question, right? We haven't done anything related to calculus at this point. Let me give you another one of these right here. How about this one? Verify, you're up. Is this the same thing? Is it asking the same thing? Arc sine, right? Same principle here. This said, okay, what do I plug in? This said, what do I plug in? What angle do I plug into sine to get 1? This is saying, what angle do you plug in to get root 3 over 2? Okay, so 60 degrees, or what's that in radians? Pi over 3. That is an order, the point that corresponds to that angle, pi over 3, 60 degrees, is 1/2 root 3 over 2. So that's exactly right. Arc sine of root 3 over 2 is saying what angle gives you a y coordinate of root 3 over 2, but you're stuck between negative pi over 2 and pi over 2. So pi over 3 is right. Okay? Again, none of this is calculus yet. We're just trying to make sure that the neurons are firing today. All right? All right, so we could do the same thing with cosine. When we have the cosine function and graph it, when we cut it, do we cut it the same way we cut the sine? Sine we cut between negative pi over 2 and pi over 2, right? Where do we cut cosine? 0 to pi. Okay, so every single one of these properties is something from pre-cal, and you might want to go back and just breeze through them again. We're not interested in these properties right now. This is just, like I said, we just want to kind of think through this again. Here's what we want to know. What are the derivatives of the inverse trig functions? Okay, if these are functions, right? If these are functions, then they should have graphs. If they have graphs, they should have slopes of tangent lines. Yes? Okay, so do we all know what the derivative of the sine function is? What's the derivative of sine of x? Cosine of x, right? What's the derivative of cosine of x? Negative sine of x. What's the derivative of tangent of x?
Secant x, tangent x.
Close, that's secant. Derivative of tangent x is secant squared x. All right? Derivative of secant x is secant x tangent x. Derivative of cosecant x is negative cosecant x cotangent x. And then derivative of cotangent x is negative cosecant squared x. The first three you should know. Derivative of sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. Those three, have them here. The other three are on a formula sheet. What we're asking now is what's the derivative of an inverse trig function? Do you understand? Different question. So to do this, and to actually answer this question, we will need to call on two different things that we learned in Cal 1. First, implicit differentiation. And then the second is using something that we used in pre-cal, which is called reference triangles. So this is going to be our first good example here. Now we're starting to talk more calculus now. If y equals arc sine of x, find y prime. By the way, in Canvas where we have all our stuff, let's see if I still have it. I don't have it up. In Canvas, where the syllabus and all those things are, there's a thing called Files. Click on that. Inside there, you're going to find all the formula sheets that you're allowed to have for this class. On all exams, you can bring the formula sheets that are in that folder to the exam and use them on the exam. So I'm not the type of instructor that will say that on the exam you have to memorize all the formulas. They're there for you, okay? But it's your job to print them out and bring them. The answer to this question is in your formula sheet. The derivative of arc sine of x is in your formula sheet, but that's not, I want to show you where the formula comes from, all right? So how can we figure out what the derivative of arc sine of x is?
Sine into the denominator to make it a positive power.
What do you mean?
So it would be 1 over sine x.
Ah, so you're being,
Derivatives, yet I'm just manipulating the formula.
yes, and you've fallen into one of the terrible notations that we use in mathematics. It's horrible. Because what you're doing is this. If I write x to the negative 1, do we all agree that means 1 over x? Right? That negative 1 is a power, it means 1 over that, right? But when we write sine inverse of x, we do not mean 1 over sine x. This is just bad notation on our part as human beings. We shouldn't have done this, which is why a lot of people will use arc sine x instead of this notation so that you don't confuse it with this negative exponent thinking it drops down. If we wanted this, what would we have used instead? Like if we meant this, what would we have written instead of that? We just would have written cosecant x, right? So this is a flaw in our notation. Be very careful with that because you don't want to fall into the trap. I use this notation almost exclusively, not because I want you to fall into